With Hess's law of heat summation, we are being asked to find the enthalpy change of what we call our target equation, given the elementary reactions to build from. What we're trying to do is somehow add the two equations below so that they create the target equation. And once we do that, we simply add their values of delta H to find the target. Whatever we do to the elementary reaction, we do the same thing to the target. IF plus F2 given IF3, its value of delta H provided. IF plus 2 fluorines give IF5, its delta H is provided. We have two building block equations to create the target. IF5 yields IF3 plus F2. I simply turn my attention to the first reactant in our target equation and start skimming through where I find the IF5 in the targets. I'm noticing that IF5 is given to me in the second equation, and it's a unique place. There is only one location of IF5. What I'm noticing is I have the right number, but it's on the wrong side of the arrow. I'm predicting that we'll need to flip or reverse the reaction for number 2. And when I do that, I know I need to change the sign. The second ingredient listed up here in the target is the IF3. IF3 appears uniquely in that first target equation. I like the number I have, and I like the side of the arrow I'm on. I bet we just leave that alone. Let's rewrite, finally showing the work we would be required. Leaving the first one alone, we'll just simply rewrite it. IF plus F2 yields IF3. Delta H has stayed the same at negative 390 kilojoules. When we rewrite that second equation, we'll flip its direction. IF5 now yields IF and 2 fluorines. Since we flipped the direction, the sign now is positive 745 kilojoules. I'm noticing here I can cancel out a fluorine, leaving me a net remainder of 1 fluorine on the product side of our second equation. I'm noticing here that IF cancels and leaves no net remainder. And indeed, we have created what our target asks us to find. We have IF5 yielding IF3 and 1 unit of F2. All that we need to do now is add those two values of delta H. Negative 390 plus positive 745 gives us an endothermic value of 355 kilojoules. The value for our target equation, positive 355 kJs.